So in this video, we're going to be working with rational zero theorems, right? So we call that a polynomial function of a degree n can have at most n real zeros. So depending on the degree, that's how many zeros it can have, right? Real zero can be rationals or irrationals. Again, real zeros can be rational or irrational. Rational zeros are those that can be written in the form of a fractions of p over q. Right? So if we have a polynomial of this form that has integers, then every rational zero of the function has the following form. So p over q, where p are the factors of the constant term, so the one without variable, and q are the factor of the leading coefficient. So let's see how we're going to work here. So right here, I'm going to first find my factors of my constant term. So in this case, so the p is all the factors of 2. So they're going to be plus or minus 1 and plus or minus 2. Right? Then q are the factors of the leading coefficient. In this case, my leading coefficient is 1. So it's plus or minus 1. Okay? So p over q, my possible list of zeros, are going to be the division of all the p's by all the q's. So in this case, it's 1 divided by 1. So it's plus or minus 1. And then plus or minus 2. Let's see what happens. See what happens when my leading coefficient is different than 1. So again, p are the constant terms, so in this case is 1. So plus or minus 1. Then q are the factors of the leading coefficient, so plus or minus 1, plus or minus 2, and plus or minus 4. Right? So I'm going to divide now all this ones, all the p's divided by all the q's. So p over q equals to 1 divided by 1, so plus or minus 1. 1 divided by 2, so plus or minus 1 half. And 1 divided by 4 plus or minus 1 over 4. Okay. So let's see 5. So again, it's 12. So p are the factors of 12. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Okay. Q are the factors of 6. So 6 plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So p over q, we're going to divide all of these factors by all of them. So it's plus or minus 1 divided by 1, right? And again, 2 by 1, 3 by 1, 4 by 1, 6 by 1, and 12 by 1. So right here I have plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Right? Now I'm going to take all of those and divide it by 2. So it's 1 divided by 2. So it's plus or minus 1 half. Then I have 2 divided by 2 is 1, it's already here. Now I have 3 over 2. So plus or minus 3 over 2. Then I have 4 divided by 2, that is 2, we already have it here. 6 divided by 2 is 3, it's already here. And then 12 divided by 2 is 6, we already have it here. Right? So now I'm going to do the same. Everything here divided by 3. So let's start with plus or minus 1 over 3. Then plus or minus 2 over 3. Then plus or minus 4 over 3. Right? Then I have 6 over 3, that is 2, is here, and then 12 over 3 is already here too. Right? This is 4. Now I'm going to divide all of this by 6. So that means that I have 1 over 6, so plus or minus 1 over 6. Then I have plus or minus 2 over 6. 2 over 6, that is 1/3, is right here. Then I have 3 over 6, that is 1/2, is already here. Then I have 4 over 6, that when I reduce that fraction is 2/3, is here. And then 12 over 6, that is 2, is right here. So 2, you should have 1, plus or minus 1, 2, 3, 6, 9, and 18, right? When the leading coefficient is 1, it's just factors of 18, right? Then on number 4, you should have 1, 2, 4, 8, 16, then 1/3, 2/3, 4/3, 8/3, and 16 over 3. Right? And then on number 6, I got 1, 2, 3, 4, 6, 8, 12, 24, 1/2, and 3/2. And that's it for this lesson. May the force be with you.